So good morning, everyone. First of all, thanks for attending one more session of the Coimbra Sustainability Summit. Today, we are going to talk about sustainable city solutions. This summit is supported by 4 EU-funded H2020 projects, mainly by Diatomic Chain and MSEC, dedicated to cybersecurity. Different speakers from 3 different regions in the world. We have Ricardo Vitrino, it's a R&D manager in Ubiware's MSME based in Aveiro. We have Ivana Podmars-Darko from the University of Zagreb, and Mathieu Gallissot from CEA in France. Yeah, maybe you?
Hi, hello everybody. So I'm Mathieu. I'm a cybersecurity architect working in CEA in Grenoble, France. So CEA is a governmental agency based on energy, mostly nuclear energy traditionally, and cybersecurity is a strong driver for us. And we have also technical projects such as the MSEC project we will present later. What I'll be presenting today is the MSEC project and a specific point we had in this project, which is how to manage the privacy in a cross-border context. So let me introduce the MSEC project. MSEC means multi-layered security. And it started from one point we have seen lately is that cybersecurity on IoT is a major challenge. As we see, there are many attacks going on lately, and these attacks have a huge impact on cyber physical systems as they damage the reputation of city, of industrials, and so on. So we wanted to bring secure IoT component for both IoT device, could be cloud with smart city application, and also to bring a novelty around smart city, which is a marketplace, somewhere when you can buy data in a secure way. And this is exactly where we have this privacy challenge, is how you can buy data, which might be personal data, and how to handle with the regulations. Our approach to cybersecurity has been totally working on end-to-end with as much as novelty we could bring. So we can start with secure IoT. As the devices are in the public space, it's quite easy for people to get one of these devices and hack them. So we can talk about software vulnerabilities, but also hardware vulnerabilities, which might get access to really strong credentials. So we've been bringing some security on these devices at the hardware level, and it propagates to the gateway if there is any, and to the cloud to have a secure communication from the device to the application. And we've been developing some newer techniques. So mostly we talk about authorization, authentication, and accounting, which are the AAA, which is quite common in IoT system. On top of this AAA, we've been adding anonymization, attestation, and auditing, which brings more primitives to create trust over this smart city architecture. This architecture and these software components will be used to deploy use case across 2 smart cities. So it's an ongoing work. We've got 2 pilot cities. One is Fujisawa in Japan. It's in the neighborhood of Tokyo. And actually it's a city where it should be used for the Olympics 2020, which has been postponed, but it's where all the sailing competition takes place in the next Olympics. And Fujisawa is really leading cities in for smart applications. And in Europe, in Spain, we have the city of Santander, which is already famous for smart cities European project, and which is also leading several use cases for these secure and trust applications. And one of the use cases I wanted to focus on is how exactly we can use this marketplace. We have in both Fujisawa and Santander, we will have citizen end users which will use their smartphones to create data. So they will take pictures, they will take environmental things, so they can participate within each other's. And the data they will be collected, we don't know yet if it will be personal data or not, but it will be collected in a blockchain. And this blockchain has great advantage for security, but also have drawbacks when we start talking about private data. And one thing, once the data is stored into the blockchain, is that third parties can access to this data, and they will most likely pay or in a way or another way to access the data and to create value on top of this. And yet again, it's a challenge for privacy. So how to deal with privacy when first we have two different regulations. One of them is GDPR in Europe. So I guess most of you know this regulation which has been active since 2016. And the other challenge is that the core technology blockchain makes by nature all the data public, which is not good at first sight with privacy. Our first challenge is to solve blockchain and GDPR, and there have been great work within the European Commission to tackle this problem. When you deal with a blockchain, one of the properties is transparency, and transparency is written as data should be publicly available. If it's a private blockchain or permission blockchain, anyway, all the data is accessible for everything participating into the blockchain. So if you have sensitive personal data such as identity, contact address, or even, for example, your sexual preference or so on, you cannot by nature make this data public, and you cannot store them into the blockchain. And another problem of the blockchain is that the data is permanent in the blockchain. You cannot by nature erase it. It's one of its property, and the right for erasure is something strong in GDPR and management for privacy. You want to ask maybe third parties to erase the data which concerns you that was created 5 or 10 years ago, because it might hurt your privacy. The European Commission has proposed several designs. One of it is homomorphisms computing. So in this design, the data is encrypted and it's stored in an encrypted way into the blockchain, and you will need the key to access the data. Another possibility is the zero knowledge proof, which when you want to access the data, you need to prove something, but without revealing it. And it's some challenges which is based on elliptic curve computing, and which is not yet mature, but which might be a huge enabler in the next year. And an easy way to do it actually is the off-chain storage. So you have a separate database which is encrypted, on which you can erase data, modify data, and so on. And then you have your blockchain on which you have the descriptors of the data and like a pointer to the database. And this is actually the solution we have been choosing for the MSEC project, with a fully secure database on top of the blockchain. So we can have a strong link between the two technologies, having the advantage of decentralized management of the blockchain, but also having the privacy compatibility with a traditional database. So for most of you which will be interested in going further into this, there is this report from the European Union, which is quite extensive, so you can deeply read it. And the second challenge we had is the regulation. So GDPR has been active since 2016 in Europe, and the equivalent in Japan is PAPA. Since 2016, it has been recognized that the two regulations provide an adequate level of protection for the end citizen, but not quite the same. So Europe and Japan has been working on creating some adequacy rules. And in 2018, there has been an adequacy law that has been promoted, which recognized by nature the two regulations as being the same. But there are still some differences that need to be a bit understood. So for example, you don't have the same complaint handling mechanisms. So in Europe, with the GDPR, you have DPOs, the data protection officer. So every company treating personal data must designate one of these DPO. And when you want to complain, for example, let's say you want to complain to a social network about your private data, you just write to this DPO, which should be accessible. And in Japan, you don't have the same designation. And there is an equivalent which has been created with the adequacy decision. One other major point is that how the public authorities can access the personal data without the end user being aware of it. And in Japan, this is something which is really important. So the public authorities can access personal data with less restriction than in Europe. For example, for law enforcement, mainly law enforcement, but also national security. And there has been a bridge which has been made with the GDPR, so the regulations are aligned. So this adequacy was promoted in 2018, and between the promotion of the GDPR and the adequacy decision, so between 2016 and 2018, one European company could tweet with a Japanese company, and both could create personal data and process personal data, but they had to justify each time additional rules. So since this adequacy, they don't have to specify additional rules, but they have to know them. These additional rules, supplementary rules, as said earlier, they are here to bridge the gaps between the two regulations. And so it's quite legal terms, and they have a lot of pages defining this. But another example is the sexual orientation and union membership, which is not considered as personal sensitive data in Japan. So it has been added. So for example, now your sexual preferences are known as sensitive data and are treated differently in Japan than it was made before. In the software components we have developed in MSEC, one of them is anonymization. And it's really important, as if your data is anonymized, it's not under the GDPR law. So it might be a source of mitigation if you have to treat personal data. And at some point, GDPR is too strong for you, and finally you don't need that data to be personal. You can anonymize it. But this process of anonymization must be irreversible. And that's a strong point in the GDPR. But this point is not specific in Japan. So the process of anonymization must be specified by your Japanese partner when you are doing a cross-border use case. To understand this gap between so sensitive data, personal data, pseudonymized data, and anonymized data, I've got a little exercise on which I'd like you to participate with a few questions. So, for example, let's say in the COVID-19 context, I want to track which people are sick or not, and I want to understand that in order to understand my business. If I just say someone, let's say Alice Rosemary is sick, and I've got this data in one of my files. For you, is it an identified data, a pseudonymous data, or anonymous data? I let you a few minutes to vote. A few seconds, sorry. So yes, as the Trump says, it's an identified data because you've got the name and surname of the people, and its sickness actually is an health data. So it's an identified data which is also sensitive. So it should be really taken against most protection, which is later. And if I want to get rid of the name and surname, I could say, okay, so the French guy speaking is sick. There is no name, so is it an identified data, pseudonymous data, or anonymous data? Okay, that was a tricky one because actually it's an identified data. You've got my name, you've got the information, and you can very quickly, with no research, link my name to the affirmation. So actually, if this was a trick, it's an identified data. Later on, so if I want really to make a separation between the name, the identity of a person and its potential sickness, so I could just, for example, create a hash with my name and just say, okay, this identifiant is sick. So for you, is it a pseudonymous data, identified data, anonymous data? Okay, so actually, it's not anonymous data, and this is where the trick is, because if you got my name and you can recreate the hash operation and just check if the hash corresponds to my name. So it's not irreversible, and it needs to be irreversible to be considered as an anonymous data. So last one is there are 263 sick people in this area. And yes, this is a way to be anonymous, and only under this, because it's not reversible. Only doing this, you can get rid of these GDPR constraints and privacy constraints. So this difference between personal data, pseudonymized data, and personal information is really the core knowledge to understand, to treat with privacy. And I just recall in this quick table the GDPR obligation you have between the different class of data. So if you have an identified data, so let's say the name and the sickness of somebody, you need to notify this person you will be collecting data, but also to obtain its informed consent to permit this person to access data, to delete data, to know when this data has been transferred, to inform why you are processing this data, to handle if you will be transposed this data to another country or not, and so on. So it's some constraint, but it's also a strong legal framework to treat personal data. When you use pseudonymous data, you are not totally anonymous, but you still have a few requirements to meet, and they are important. So to go from identified data from pseudonymous data, we need to know that you cannot identify technically. You can have a paper mark with the link between the pseudo and the name, but hacker shouldn't do it by just hacking a system. And as we've seen before, from going to pseudonymous data to anonymous data, it must be also irreversible. Okay, and these concepts are quite important in the COVID-19 case because most of countries have developed tracing application to know between your neighborhood if you have been in contact or not with potentially sick people, and if so, to prevent you and to put you into a quarantine or so on. And most people, most of some scientific has been raising concerns about this, and especially regarding privacy. So this is one of the stories in which you can break this to know really if somebody has been sick or not. And it's a simple story. Let's say one company wants to hire 3 people, but don't want to hire somebody which has been sick. So 3 people, meaning that the people doing the interview will have 3 smartphones. One is for smartphone A, smartphone B, and smartphone C. And every time the interviewer has an interview with one of the person, he just turn on the smartphone with the application during the interview time. And so the proximity can be measured by the application. And with the next person, you will turn on a different smartphone. And you can wait for 10, 14 days, 20 days, no matter. And each smartphone will inform you if you have been in proximity with a sick people. And at the end, as you've been interviewing them, you know exactly their identity. And for something which was presumed as pseudonymized data, and you've got personal information. So the COVID-19 has really tackled on this problem of privacy and make the distinction. So I hope it will be helpful for most of you to have a better insight of private data, specific data, and also how to manage cross-border application. I will be, of course, available later if you have any question, and I'd like to thank you all.